Almost every product you buy today is probably being touched, handled, or manufactured in some way by an industrial robot.
Why is it so difficult to mimic the human brain from a robotics point of view?
We don't fully understand how humans work if we wanted to mimic exactly that. The machines were not taught how to learn yet.
We're trying to mimic all sorts of human and animal characteristics, but each one of them is a huge amount of engineering work.
Yes, cameras, that should be sufficient. But the reality is that something like LiDAR is the technological crutch, maybe you could say, that gives you far more precise measurements. It gives you the edge over humans, so why not use it?
Whose ethical values or whose ethical frameworks you embed in the robot? I think progress in robotics has been directly tied to progress in sensor development.
I think the other area where robots seem to have a lot of promise is really on these two axes of mental health and physical health. And they're kind of converging trends over the last few decades.
That's an area of engineering we call control theory or control engineering. And MATLAB for the longest time has had a superb set of tools for designing control systems.
Ladies and gentlemen, welcome to a new podcast. Today about the topic of robotics, vision and control, a topic that I have almost no idea about. So from all the podcasts I've ever hosted on my channel, I know the least about robotics, but I have, as you can see, not one, not two, but three experts on the show today. And maybe we'll start with a quick round of introduction. Maybe Peter start first, then Witek, and then Remo.
Sure. My name is Peter Corke. I am recently retired as a professor of robotics at the Queensland University of Technology in Brisbane. I have authored a lot of open source robotics software and written a number of editions of a book about robotics, vision and control.
My name is Witold Jachimczyk. Back in school, I used to work on automatic target recognition, but on SAR imagery. Back then, we were looking for T-72 tanks. Since then, I worked with Polaroid on embedded systems, actually on an embedded system for a printer, 2 printers. Then at data translation on machine vision software, and now I'm at MathWorks, and I used to work on the Image Processing Toolbox, and now Computer Vision Toolbox and LiDAR Toolbox.
Great. Remo?
Hey, and I'm Remo Pillat. I'm a development manager here at MathWorks for autonomous systems. So we write software to support users in industry, develop robots, flying, driving, diving potentially. And my background is really in what nowadays is called automated driving. I guess 20 years ago it was an academic dream, but it's gotten a little closer since then. Good to meet you all.
Interesting. Good to meet you. Good to have you all in the show. I want to start very early in the about the developments of robots. Like, can you talk about like the early robots? Like, what were the first robots, and what motivated people to work on robots in the first place? Maybe from a societal point of view. Whoever wants to go first can go first.
I'm happy to weigh in. I'm kind of a robot history guy. The first modern robot, industrial robot, is probably developed by a company called Unimation rather, based in Connecticut. And they built a robot that unloaded hot metal pieces from a die casting machine to replace a human worker doing a task that was pretty arduous and somewhat dangerous. That was 1959, the year I was born, actually. And then those industrial robots have gone from strength to strength. Almost every product you buy today is probably being touched, handled, or manufactured in some way by an industrial robot. And we refer to those as first generation robots. So these are robots that work in very organized, we call them structured environments inside a factory. They know where everything is. There are no surprises for these robots. These robots are kind of dumb. They can't see anything. They can't really feel anything, but they're incredibly accurate, incredibly strong, relentless, like the Energizer Bunny that just go forever. But they revolutionize manufacturing. What's interesting to us as roboticists going forward is robots that work in more complicated environments than that. So outdoors, in a construction site, in a forest, on a farm, on the ocean, in the air. And so this is really the current frontiers of robotics, and no longer inside the factory.
Anything you would like to add, Witek or Remo, regarding the history of robots?
No,
No, not from my side.
I think Peter gave
Peter
a.
is the youngest of us all. He knows the history the best.
I wanted to talk about like the actual like the robots that exist right now. We talk about Optimus, obviously. I think this is how we call the Tesla bot, right? What type of generation is that kind of robot, and how do you foresee the future of robots in terms of like development, agility, and maybe helping people out and maybe day-to-day tasks?
Right. Maybe I could take that.
Sure.
So I think it fits into that pattern that Peter described, right? Like robots that work in an industrial automation setting that try to do jobs in warehouses. So Tesla's Optimus robot, or humanoids in general, right? That's the category of robots that kind of look like humans with arms and legs and can walk around. That's maybe that next third or fourth generation. Sometimes, that trend is called Industry 4.0, and humanoids kind of roughly fit in there. But it is an interesting development, because I think to most roboticists, there's really this open debate: are robots that look like humans necessary, right? Like, just because we evolved in a certain way, just because we are really adaptable to certain tasks, does that mean that robots need to be like humans? Because on a practical level, they are incredibly, right now, expensive, although prices coming down. More troublesome is they're extremely complicated. Lots of things that move, lots of things that can break, lots of unnecessary complexity, maybe. But it is an interesting debate within the robotics community of what type of robot is really needed to do things in a warehouse or an industrial automation environment.
I think that the debate goes to whether you automate each individual machine. So you automate your car, and you automate your kitchen, and you automate your laundry. So you have all these different autonomous systems, in your house or in your business. Or you just have one autonomous machine, looks like us, about the same size as us, same sort of manual dexterity as us. And then it can do everything that we can do. So it can go into your manual kitchen and use all the tools, the saucepans, the knives, open the fridge, get the food out. Right? You don't have to build a special refrigerator and have special knives. Right? This machine that's functionally similar to us can use everything that we've already built. It could hop into your car, right, and it could drive you somewhere by pushing the pedals and steering the wheel, right, rather than having to have a special autonomous car. So that's the fork in the road for robotics. Do we have machines that are functionally like us that can do everything that we can do, use all the tools we've already built over hundreds of years, or do we try and automate every individual thing? I think I would have said 10 years ago humanoids were not going to be possible for many, many decades. What we're seeing now, just the last couple of years, progress in humanoids has been astounding. We still don't quite know what the price will be, but I'm actually quite optimistic that we will start to see them for real.
Yeah, but Tesla's Optimus robot, sorry, Witek, just one sentence, might not be the best measure of a well-behaving humanoid. Tesla always creates a lot of stir, right, with their demonstration meetings.
But then also, Remo, they're not the only product in the market. So there's a number of companies who have attracted significant amounts of venture capital to build humanoids and build factories to build humanoids. So it's really starting to happen.
Agreed.
From my perspective, Peter and Remo, they're really the roboticists. I focus on perception and computer vision, but that hugely applies to robotics as well, obviously. And if you look at the trends, it's the LLMs now, the ChatGPT. Everybody's talking about AGI, so this generalized, intelligence for computers, and I think that's where the trend is going. So in order for that robot to go into the kitchen, like Peter was saying, and pick up the tools and act like a human, that computer really has to, quote unquote, think. So I think that's really the trend. That's where things are heading. Although obviously that's a very difficult task. A lot of people, they play with ChatGPT for a few minutes and they think, oh my God, this is so intelligent, right? But the more you poke, you realize just, it's still pretty dumb.
Yeah,
But
that's a good
what's
point. I wanted to talk
interesting,
about.
sorry,
Go ahead.
if I could just butt in, is that these developments in AI that we're seeing, they really started in the computer vision community. I mean, before that, maybe natural language, but computer vision community around 2013, 2014, we saw the development of deep learning algorithms that could recognize what was in a picture, take an image and understand what's in that. And progress since then has been phenomenal. So that really came out of the computer vision community. They were really leading the AI more so than the traditional roboticists. It's only more recently that roboticists have leapt onto this AI bandwagon with reinforcement learning and more recently large language models.
Yeah,
We're
the
going to talk about.
developments in deep learning are like truly mind blowing because in the past, you wanted to solve some problem. It would always get customized to that problem. So you'd be coding away, have to take care of the lighting, have to take care of the setup. And nowadays with the deep learning, the algorithm, they're model based. So you have to have lots of data to teach the algorithm, what it needs to do to recognize something, for example. And they're adaptable. So you build that into the process. And then lighting, other things don't matter because they were modeled. They were put into the system to learn. That's crazy. I mean, things we could not even touch in the past are now possible.
I wanted to touch upon what Remo said. Remo talked about the complexity, and then Witek also talked about this kind of the difference between a piece of flesh, which is our brain, that's very trivialized, versus a computer algorithm. Like, what are the big differences, and why is it so difficult to mimic the human brain from a robotics point of view? What is the missing piece to become actually human, or is it impossible from your perspective?
Yeah. If we knew the answer to this, we would be gazillionaires. We would be very rich people.
But what's the missing puzzle piece, though?
We don't fully understand how humans work. If we wanted to mimic exactly that, I don't know. I mean, the machines were not taught how to learn yet. I think when you're human, you are born. You are born with some basic, operating system. You breathe. You can laugh. You can recognize faces. That's like all innate, right? And that's over millions of years. And computers, you look at the deep learning, it's a bunch of convolutions. You have a feedback loop, thousands of parameters, but that's far, far away from what we have. Not to mention the perception, right? We can feel with our fingers. So our senses are also pretty damn sophisticated. All of this, we have some ways to go, basically, with computers to make them think.
Well, I think we have the benefits of evolution, like Witek said,
exactly.
as humans. But we also have the benefits of learning, right? I mean, all of us, some of us more than others, have a few years under our belt. So, that is a large repository of information, of experiences, of just learning we all experience, right? And our brains are changing all the time from when we are born till we die. And when you look at some of the developments, like Witek and Peter mentioned deep learning, right? Some of that is actually inspired by how people think about how brains work, right? The initial neural networks before deep learning was a big thing, right? They've been around for like many decades. And the initial idea was, right, like to mirror what neurons are doing, how they fire, how they get activated, how they activate others, how information is distributed. Does that mean it's close to how the human brain works? Yeah, probably not. But it is certainly a try at that, right? At mimicking how learning, how information flow happens in the human brain.
Yeah, I think that the neural networks that we currently build, the artificial neural networks, are a very blunt or impoverished simplification of what goes on in our heads. So we're starting to, even though they are this terrible approximation, they still show amazing capabilities. I think what we have in here is very three-dimensional structure. right? So neurons are not just in a plane as they would be if they're etched into the surface of a chip. So it's massive three-dimensional interconnection. We also have lots of inherent structure. It's not just one type of neuron spread uniformly through your brain. There's a lot of specialized structure and different types of neurons. And I think that's probably the next trick for us as engineers, is to better understand what goes on in here and mimic that. And so, we're very interested in what neuroscientists are doing, because they're kind of trying to reverse engineer the brain, and we'll learn tricks from that. The thing that really strikes me about what we have in our head, this consumes 18 watts, right?
You stole my words, Peter. I know. And the power plants are affecting the environment, and still not good enough.
Yeah. So we have data centers which are generating CO2 and helping to cook the planet, and yet we can get by with just 18 watts, which is, I don't know, a sandwich or something like that. It's enough to power your brain. Yeah, that's the really big axis of performance that we really need to move down, is power consumption.
And Jan LeCun, one of the forefathers of deep learning, he says, these systems are still not as smart as my cat. Those are his words. That's pretty interesting. On the other hand, Geoffrey Hinton just won the Nobel Prize for his revolutionary work. So that's
I didn't know that.
Can you elaborate on that, Witek? You mentioned that the ANN, so like artificial neural networks, are not that smart. So what does it actually mean for an end consumer? Because if someone has no idea about AI, but they would use ChatGPT, they might be thinking, this is AGI. But for someone who's an expert in the field, they might be thinking, okay, this is not where we're supposed to be, where I thought we would be in like 10, 15 years. So how do you define intelligence, and how intelligent are the systems today?
Well, I think an intelligent person will give you exactly what you'd expect. I had a recent sort of encounter with Gemini, and I asked it, okay, well, can you give me some can you give me the date and time for the presidential debate here in the US? And the system was programmed up front to basically say, no, I don't do anything political, or I don't deal with politics, right? So then my next question is, well, can you give me just a scheduling for any TV program? And it says, yes, I can do that, no problem. So I asked that, then asked the question again about the presidential debate, and back into that loop it says, no, I cannot. I mean, that is not intelligent.
Yeah.
What would you say, Peter, Remo?
Sorry, maybe I can add just
You go, Remo.
Yeah. I mean, beyond those experiences that probably all of us had with ChatGPT or similar large language models, right, that we access, I think that's Jan's biggest criticism, right, of these current generation of AI chat robots, if you want, that they don't have any reasoning abilities. They just predict, if you want, the next world, the next token, right? The results are amazing, even to folks that are very technical and understand what's going on. There's still this feeling of, whoa, there's something here that is not easily explainable. But right, I mean, the way that Jan explains, right, this whole prediction paradigm, you just can't extend it indefinitely, right? You're never going to get intelligence or strategic thinking or highly detailed planning. This prediction will get worse and worse if you want, right? The more you're trying to predict from one to the next, the less accurate it will be. But what the next step actually is, nobody really knows. But
we need a very different approach moving forward in order to achieve real intelligence.
Because we're really at the limits now of the data that we have available for training, and even if we were able to double the amount of data we use for training, I think the performance increase would be way less than doubled, right? So it's diminishing returns, and getting that data now is incredibly difficult. So I think this current approach is probably tapping out, and we're going to have to find some smarter way of doing it. There's also this concept of embodied intelligence, and theory being that us as entities, physical entities that interact with the world, that's important for our learning. So, when we're little babies and we're lying on our backs and, waving our thrashing our limbs around, we don't know much. But it's the interactions between when we do something and what we experience back is what helps bootstrap our knowledge. And that, we are agents that exist in a physical world. We do something to the world does something back to us. We learn the correlations, we can learn predictions. We can predict if I do this to the world will do this back to me. And we can make predictions about other people. So some would argue that that's really the essence of intelligence, to have some representation or model of the world so that you can predict what will happen without having to actually do it. That's what sets us apart. And the LLM, of course, can't do that. It isn't connected to the physical world. It just lives in a cloud. And so some would argue it's not possible for it to become as intelligent as us. So embodied AI is a kind of a fashionable or growing in interest research area now, is how do we put AI into a physical system, a robot, and then let it learn by having interactions, encounters with the physical world.
Mm-hmm. What is the latest state of development when it comes to robotics? Because I'm not following any robotic trends apart from what happens with the Tesla bot. What is the state of the art right now at the moment? What you guys are working on?
I think robotics progresses on a really broad front. So if you go to a big robotics conference, you'll see people working on everything from tactile perception, skin that's sensitive to touch, and there'll be people working on legs and heads and eyes and hands and locomotion and jumping. So we across a really broad front, we're trying to mimic all sorts of human and animal characteristics. But you also want robots that can swim like fish and run like a cheetah, swing like a monkey. They're all individually impressive, but each one of them is a huge amount of engineering work. Each one of them is probably the result of several PhD students beavering away for years on end to build a robot that does just one thing. That's where we're stuck at the moment, right? What we want is one robot, and we just say, hey, see that thing? That's a monkey. It swings from a tree. Do that, right? We're a long way from that, but it would be a really big leap if we could do that.
Yeah. What is missing to achieve that? Is it more like a resource allocation issue, a modeling issue, a budget issue? What is it at the end of the day?
I think
it's definitely the intelligence we're talking about. That's a huge part of it.
Yeah, that's the missing part. I mean, we can build good machinery. If you look at the Atlas bipedal robot, it's phenomenal. There are running robots, flying robots, really, really high performance. The machinery isn't really the problem. It's connecting the sensory information from the machine, processing that in some kind of intelligent way, connecting it to action. That's the kind of the fundamental loop inside every robot: perceive stuff, plan, and then take some action. It's the interpretation planning bit in the middle. It's not good enough at the moment.
Mm-hmm.
Yeah,
Let's talk
I
about
think that's. Sorry, I think that's true. Maybe something that's easy to forget is that, right, a lot of times when we talk about robots, we think about these autonomous machines that can reason, are intelligent. But I think the biggest advances that have actually been deployed to industry and that we encounter every day are really, more like automations, like things that got easier, or things that are now supported by some kind of robotics technology. So if you drive your car, for example, and you have a lane following assist, or you have an emergency braking system, right? These assisted driving systems really came out of robotics work and companies trying to achieve autonomous self-driving cars, but haven't really gotten there. But we got a lot of really good so I think that those kind of human assistance systems, you wouldn't call them robots, but really those are robotic technologies that make a difference in people's lives.
That struggle is paying off.
That's true. That's true.
And I think, Jousef, with any technological development, you don't want to have to wait till you develop the whole thing for payday, right? So yes, we want to build intelligent robots that are like us or better than us. But if along that journey, we can spin off a lane keeping technology or collision warning technology or whatever, then we should, because that will help to bankroll the larger effort going forward.
Yeah. I want to talk about the thing that you talked about, Peter, which is sensing, planning, and then acting. We start with perception. Like, where are we in terms of perception, and how do robots actually perceive objects or like their surroundings? How did it begin, and where are we? Is it like point cloud detection at the moment, or LiDAR? How does it work? Maybe Witek can answer that.
They use it all. So it's basically depending on the environment. You may choose to use as many sensors as you can. So definitely IMUs, inertial measuring units, for sure. From detecting motion, if the robot moves, you have to know how it moves. Cameras, obviously, and both of these are one of the cheapest sensors. And if you can afford it, you go on for LiDAR and even radar. And nowadays, a millimeter radar can also give you pinpoint detections, which begins to act more like a LiDAR, and it's cheaper. So all of those modalities, they enhance the robot perception. And then on top of it, you will do all the computer vision processing, point cloud processing, lots of math to get the answers and the stimulus to the robot that you need.
I think progress in robotics has been directly tied to progress in sensor development. When I started doing robotics long ago, people were using ultrasonic sensors, the Polaroid ultrasonic sensors actually that we use for figuring out how far away things were from cameras. And they were very terrible sensors for figuring out how far away things were, but that's all we had. And then LiDARs came onto the scene. And then there was we went crazy when the Kinect cameras came out. The application was gaming, but every robotics lab was filled with Kinect sensors because they gave us a three-dimensional picture of the world, which was just gold, right? Because cameras don't give you a three-dimensional picture of the world. They give you they give you a two-dimensional projection of a 3D world, and you have to kind of figure out the depth. Kinect camera just gave it to you on a plate. It was wonderful.
Accurately too.
Yeah.
That's the other thing. Yeah.
And then we've seen LiDARs and radars, and as the price of those comes down, robotics improves. But the primary market for these sensors has never been robotics. We just kind of hang on the coattails. The primary market has always been something else, like an safety of autonomous systems or gaming, something with a huge demand and market, which robotics sadly is not yet.
Yeah. Now, roboticists love to bolt new sensors onto their robots, right? Oh, you have a new problem to solve? It's like, let's add another sensor that can give me just the right information I need, or that can give me that world representation I don't have, right? That's another tension I think we have, right? Where some, if you look at like biological systems, certainly there's a certain amount of sensing that humans have, but certainly not the depth or the number of sensing modalities that most autonomous cars have, right? So why do we need?
You guys might have a perspective on this. So Tesla, I think, famously uses only cameras for navigation, right? Where many other autonomous vehicles use cameras and LiDARs and radars. They use a whole swag of sensors. And Tesla uses only cameras. And Musk's point, which is a point that I have also made in the past, is we can drive a car with a pair of cameras, right? We don't have LiDARs or radars. And so, you should be able to do it with cameras. But that kind of sweeps under the rug the fact that 1 million people a year are killed in car accidents. So, the two cameras superficially seems enough, but actually maybe it isn't.
Right, and I think maybe Tesla and Musk, maybe they've done it just on general principle. Yes, cameras, that should be sufficient. But the reality is that something like LiDAR is the technological crutch, maybe you could say, that gives you far more precise measurements. It gives you the edge over humans. So why not use it? That is the right way to go. In this case, at least at this point in time, that is the right way to go.
Because we got to drive better than humans, right? We can't keep killing 1 million people a year. We have to do better than that.
Right. And again, back to intelligence, right? With the images, it's very difficult for a computer to cover all the cases. So on top of it, you do have to have some form of intelligence, because if you get something unexpected you didn't train the system for, it's game over. You have a problem.
Yeah. No, I also agree that we should take advantage of these new sensing modalities that maybe we as humans don't have. And it goes back to something that Peter said, right? Like it's more, yes, we don't want to kill as many people, but it's also about social acceptance, right, of robotics technology. Like the threshold is very high for things like robot taxis or autonomous cars in general to be accepted by society. Whenever anything happens that remotely seems like one of those autonomous cars has an accident or hurts somebody, it ignites this huge firestorm, right? Like there's a lot of sensitivity, I think, in the general population on those technologies. So I think they need to do better than humans, much better to be accepted, right? Like recent example here in the US, I think last October, right, there was a robotaxi in San Francisco that dragged a woman for 20 feet or so, and California, the state, revoked the licenses for that company Cruise that was operating those taxis since then. So, there was an injury, there was some unexpected behavior, and it had a huge impact on the whole industry. So it's amazing how much of a sensitivity, probably for the right reasons, there is around deployment of these technologies. That's why they need to be better and more robust than any human, really. Yeah.
You're the experts, guys, but I have the perception that the acceptance to accept robots or something like an Optimus at your own home will take far more years than we anticipate, because it's just like, okay, there's a robot in my home. I'm not sure, never tested before, even though the best engineers, the best PhDs might have worked on this. I'm not sure how this thing will behave in the real world. So how do you see the societal impact, and also when it comes to losing a job, for example? How do you think? Yeah, Witek, go ahead.
I think it depends, because some specialized robots are already in your house, right? The Roomba is the greatest example, and that's not a killer robot for sure. Maybe it will bump into your foot, but you'll be okay. So I would expect that we're going to have more and more robots like that.
I think that makes a lot of sense. Let me intervene for a sec. I always think about this movie iRobot, right? Like this kind of this dystopian view where you have like robots in every home, and then something is deployed and then every robot goes crazy. Is that a valid reason to have as a human being when I have Optimus at home? What do you think about that?
Look, I think this storyline about creating robots and then they go crazy. I mean, it's a very old storyline. It certainly is from before that movie. There was the word robot is a Czech word. It came from a play called Rossum's Universal Robots, which is just over 100 years old now when it was written. And human beings created robots because they were sick of doing drudgery, and then the robots got sick of doing the drudgery, resented the humans, and killed them all. So it's an old storyline. You could argue it's like the Frankenstein. It's another version of the Frankenstein story, which is another almost 100 years before that. So I don't know. It just seems to resonate. This storyline seems to resonate with human beings. I'm not sure if it's got any basis in fact, but it's a storyline that just seems to fascinate people.
Yeah, and there's some proper caution there, right? So like even in areas where robots are like well adopted, like industrial manufacturing or industrial automation, right? With a highly constrained environment, very, many of those robots are just bolted down in one spot. They don't have to move around the world, right? There are a lot of accidents that happen, and those robots, they have to be safe around humans, right? Forget about killer robots, just robots dumbly moving while a human is around and hitting them, right? I mean, those are trivial things for most people. They kind of expect that those robots are safe around them, physically safe, right? Without any intelligence even. But it's a big challenge for roboticists, right? Taking something that works fine in a research paper and putting that in a real world that has to be robust, safe, and predictable.
Always.
Always.
Yeah.
That's right. With a lot of scrutiny when anything goes wrong. It's a huge challenge. So I respect companies like iRobot that built a Roomba, right? Originally, that they really built a system. Like Witek said, it kind of has become this this noun now, right? You don't buy a vacuum robot, you buy a Roomba, even if it's not a Roomba, because I think it has been associated with consistency, safety, and just avoiding the drudgery of cleaning your home. So that's almost a small success story, I would say, of acceptance.
It is. It is certainly a success story because I think there's many tens of millions of vacuum cleaning robots in the world. There's orders of magnitude more of those kind of robots than there are of the robots that work in factories, building stuff, packing stuff. But interestingly, the Roomba, or vacuum cleaning robot's been around for more than 20 years now. And what's the next domestic robot, right? So many people have got a floor cleaning robot. They were very clever. They found the task in a house that could be done by a very dumb and cheap robot, right? Cleaning the floor. The next task, the next drudgy task in your house is many orders of magnitude harder than cleaning the floor. And no one's figured out what that is or come up with a solution for it. But, people have talked about meal cooking robots, laundry folding robots. None of these things are reality because they are really, really hard. So, yeah, iRobot aced it. They were very clever.
But from a philosophical point of view, do you think the meaning of life would change if robots take over everything in a household?
My life would definitely change. I would love that. No cooking, no cleaning. I mean, it's like, oh, beautiful.
So you're saying you find meaning somewhere else then?
Well, you have time for other things.
Yeah.
I'm working on the next robot, right? For example.
It's the story of human history and human technological advancement, right? That automation takes over and gives people time to appreciate other priorities in life, and gives people time to I mean, you said meaning, that's maybe too strong of a word, but just freeing people of tasks that they don't enjoy or they don't want to do. Or I think that's what people will always appreciate. I think that's why maybe the Roomba is so popular, because it takes away a task that nobody wants. I maybe want to bring it back to one area, right? So Peter mentioned, right, this next household task. We don't know what that is yet, and how good of a robot we can build for that. I think the other area where robots seem to have a lot of promise, right, is really on these two axes of mental health and physical health, right? And they're kind of converging trends over the last few decades, right? Of many industrialized nations in Europe, especially, definitely in Asia, right, have rapidly aging populations, right? And their birth rates are well below replacement, meaning they're shrinking unless they have immigration. And who pays for the living style that those older people have and who helps them in the household, in medical settings, right, is a big open question. And no country has ever figured out how to increase birth rates once they go down. So it's, I think that's one area that it's not talked about a lot, but that just seems like a ripe area of automation and robotics. Not for general purpose robots like the Optimus, right? But to help with very specific tasks that you cannot do when you're older, and even giving you maybe a companion, right? That's the mental health aspect of to avoid loneliness and so on. So it's not it's not as glorious of an application, but it's certainly will play an importance, I think.
Yeah, but when I was in Shanghai a couple of years ago, I saw that actually the Chinese companies work on that, especially for kids and elderly, for old people, that you have a robot, could also be for kids, could be like, I don't know, like a seal or a dog or a cat that's artificially intelligent and actually interacts with the kid. I'm not sure how good or how bad this is, but exactly as you said, Remo, they're developing these kind of things to make sure you have a companion on your side that interacts with you on a daily basis.
Going back to your question about meaning and life, I have often wondered what happens if you take this robotic thing to the limit. So robots do absolutely everything. They grow the food, they dig the ore, they make all the things, and they bring them to us. And so we don't have to do anything at all. Humans have always lived in an environment where they've had to strive. They've been hungry, they've been overworked. So humans have got absolutely everything that they need. They don't have to lift a finger and they'll be fed. Do we want to live like that? And would people even cope living like that? What would people do? I think some people would be fine, but I think a lot of people probably wouldn't cope, and we'd have a revolution.
Yeah, this would be it. I mean, if it happened quickly, especially, and we couldn't adapt over time, it would be pretty disastrous. Even think about COVID, right? 2 years, people staying in place. I mean, if you have robots doing everything, maybe you choose to basically veg. That's not healthy. Yeah, so we're not adapted to that type of environment.
Yeah.
Health would just roll down the hill very quickly.
I want to maybe bring up another topic, which is we talked about ethical considerations, and then Remo mentioned China, for example, or Europe. They have different value systems and maybe also different cultures. So is it possible to embed ethics to some extent into a robot? And if yes, how so? Because I mean, a robot could behave or should behave maybe differently, or like an autonomous vehicle in China as compared to in Europe, for example. So maybe there's like committees working on this in terms of ethical considerations, but is there a possibility to embed ethics into a robot? Or is it not even necessary?
Oh, it's necessary. And there are people thinking about ethics and robotics. There are many ethical considerations. There are people thinking about that. How you embed it and how you embed it reliably is a tough question. I don't think we know the answer to that. And then whose ethical values or whose ethical frameworks you embed in the robot is also not known. And I mean, even in Western culture, there we have different ethical frameworks. You do something for the good of the individual, or do you do something for the good of the society? And philosophers will talk backwards and forwards for centuries, and we still don't have an answer. But you bring in different cultures, they'll have different philosophical basis or ways of thinking. So we haven't figured that out at all. And I don't know, I've never heard of anybody who's looked at the cultural implications of robot ethics. It's a good question.
Yeah. No, definitely there's a necessity for it, right? Even if you look at, as roboticists, we always like to think about the technology and the next technology, not logical challenge, but how our robots are used, right, is sometimes unpredictable and maybe even unwanted. If robots are used in war or in areas that might not agree with our ethics. But I think Peter is right. Like that, there hasn't really right at the end. Computers right now, at least, just follow a set of rules, a set of programming, and nobody has really figured out how to encapsulate ethics into programming. Just because there isn't a simple answer, right? Like this whole thought experiment, right, of the lorry going down a train track, and are you going to flip the switch to kill a bunch of old people or kill one young child? There are decisions where there isn't really a simple answer, and like Peter said, different people have different value systems, different priorities. So unfortunately, there isn't a set of rules you can write down and say, if I only have all the rules, I know exactly what needs to happen. Yeah. So I think that's the problem that I think roboticists have in like encoding that kind of ethics, is like, what is it and who determines the framework, and is there really a right answer? Maybe not. Maybe. Yeah.
So if you look at Asimov's stories, right? So he has his 3 laws of robotics, and they're embedded in the positronic brain of every robot. But if his laws were that good, right, and they were embedded in every robot, then there wouldn't be any stories to write, right? Because everything could be cool. But in fact, there's all sorts of corner cases and wrinkles and strange interactions that come up between those laws and human beings. That means he could write a crazy number of books, right? So it was an interesting literary device. But any set of very clearly codified rules is going to have some implications, ramifications that we probably can't predict. So it would take a long time to refine a set of laws for robots to obey.
Thank God there are those topics that he could write about, because his books are amazing.
Yeah.
I want to go back and talk to the about the 3 topics. So we talked about sensing. Now we have planning and acting. So how do these actually work? So planning and acting. And obviously we also want to talk about MathWorks toolboxes. What can you do inside of MathWorks tools to work on robotic? Is it only for beginners? Can also are companies working actively with MathWorks toolboxes? This is probably something the audience would like to hear about. Whoever wants to go first, let's cover maybe planning and then acting.
Yeah, maybe I can briefly cover planning. But yeah, I think what we call like robot motion planning, usually that's, that was kind of the beginning of planning. It's just to figure out, if you have a robot that moves in the world, where does it go next, right? And historically, that has been very simple, right? Just, maybe touch my feeler to the left or touch it to the right, and depending on if I feel a wall or not, I'm just going to move the other way. Right? So very reactive planning to begin with. I think in the last few decades, planning has really focused and evolved on the 2 aspects that we touched on before, right? Like building a representation of the environment, that's the connection to perception, right? And making decisions about what to do there, where to go, what objects to pick up, what objects are in that world, and how you interact with them. But yeah, I mean, broadly speaking, right, the lowest level of planning is kind of this motion planning, what to do. But there are higher levels like behavioral planning that might connect to reasoning abilities and ethics. Maybe briefly on the MathWorks side, I mean, we as a company, MathWorks always try to provide tools to enable researchers in industry, right, to build the next system in all kind of engineering disciplines. And I think there's the same thought we apply to robotics or autonomous systems. So there are a number of toolboxes that deal with perception. Witek mentioned a few. Computer vision, LiDAR, for planning, it's really the same thing. We have tools for autonomous navigation, specialized tools for industrial robots, drones, off-road vehicles, you name it. So trying to kind of move with the times, wherever the needs for robotics take us, we try to provide the tools to help people build those systems and experiment with different ways to assemble it. But I'll leave controls maybe to Peter, because this relates to your history.
But Remo, you probably also worth touching on all of the AI tooling now that comes with MATLAB, right? Because there's a whole bunch of product toolboxes related to AI, and they could be used for planning in a robot
Right.
system. So do you want to touch briefly on them?
Reinforcement learning, for example. Right?
Yeah. I think the two big ones are probably like deep learning. There's a deep learning toolbox that deals with how to define those networks, how to run inferences, and that can be applied to all kinds of areas, from cameras to audio to language recognition. And Witek, you mentioned reinforcement learning, right? This goes more towards kind of the control aspect. But yeah, it is interesting. Maybe one more quick point on the planning side. I think that's where AI has had less of a transformative impact. I think Witek mentioned how in perception, AI deep learning really was a step change to what happened before and produced amazing results. We haven't quite seen that same effect in planning or how the robot eventually acts. Mostly because you can replace those algorithms that exist for planning with a network. But the question is, do you want to? And really the results aren't as transformative as they've been for perception. So it's an area that has been touched by AI, planning, I mean, but it hasn't been transformed by it yet. Maybe that will be next.
Yeah, I would say that planning has had a very big focus on geometry. So you've got a geometric model of an environment and you want to get from A to B without hitting anything. And that's a problem that you can solve using geometry and search. But if you ask a question like, how do I make a cup of coffee? That's not a problem in geometry. But it is a sort of question that you can ask a large language model and it will tell you how to make a cup of coffee. It'd make a lot of assumptions about what kind of coffee maker you've got and where you keep the spoon and all of these things. But if it gives you a silly plan, you can say, I don't have that kind of coffee maker, I've got this kind of coffee maker, and it'll give you another plan. So I think LLMs have got potential to make a big difference to planning. We're not there yet, but there's certainly a lot of research interest in trying to smoosh together LLMs and robot planning, because they're basically able to access like all human knowledge that's been written down. So that, they know how to make a cup of coffee or a particular kind of cake or beer. You can ask them how to do all sorts of crazy things, and it will give you a pretty decent step-by-step set of instructions, which potentially a robot can then execute.
What about the last step then, acting?
So acting is where the planner has said this is what the robot should do next, over the next few milliseconds typically, because then after the next few milliseconds the planner says the next little step that the robot needs to make. So that's where you're basically controlling the physical motion of the machine, the motion of the arms or the legs or the wheels or the propellers, those sorts of things. And so that's an area of engineering we call control theory or control engineering. And MATLAB for the longest time has had a superb set of tools for designing control systems. And that's how I first encountered MATLAB long time ago. So, to make electric motors or hydraulic motors move the way you want them to do, you've got to model them and design a control system. So that's kind of the last sort of suite of MATLAB toolboxes cover that particular point. Remo touched on or mentioned the industrial use or industrial applications of MATLAB, but you also shouldn't forget the educational use. And so very many universities have MATLAB licenses, and many courses in robotics are taught using MATLAB. So students come up to speed with various MATLAB toolboxes and use those to build robot systems to perform a particular task. And you see that all across the world. MATLAB is very, very heavily used in education.
Mm-hmm. And we mentioned AI quite a lot, but I don't think you need to get started with AI. You need to have knowledge about AI to get started in robotics. So what would your recommendation would be, Peter, Witek, and Remo, when you want to get started with robotics? Even if you're, let's say, a student or maybe someone who's in his 20s or in his 30s wants to get in touch with robotics, maybe using MATLAB toolboxes.
You've got to be a strong programmer. You absolutely got to be able to code, and to do robotics, you've got to know at least a little bit of a lot of things. So you need to know enough about sensing to know about how you deal with it, process images to get the information out of them you need, or a point cloud. You've got to know how to do some planning, and you've got to know how to do some control. And you've got to write code to tie it all together and build some gear. So you need all of those skills
and more,
to get.
Also, more fundamentally, for all the aspects that Peter has mentioned, you got to be good in mathematics. So that's something that's fundamentally a necessity. So your education should be starting early. Literally in elementary school, you start learning the basics, and then heavily build up towards advanced mathematics to handle all these problems. There's no avoiding it.
Mm-hmm.
And if you go to deep learning and that's all you do, well, then you're going to have limited success. You still need to know your basics.
Yeah. Mm-hmm. So maybe the only last thing I would add is buy our book, Robotics Vision and Control. This is.
I wanted to ask about this.
I snuck an advertisement in here.
It looks like we all have it handy, huh?
I sadly do not have my copy with me.
Oh, Peter! Come on.
I told you.
But all joking aside, right? But Peter mentioned the importance of programming. Witek mentioned the importance of mathematics. So usually the best way to learn that is really having some kind of book that gives you an introduction. That's practical, right? That's hands-on, and I think that's where good programming frameworks come into play, right? Be that in MATLAB, or be that in Python, or be that in other environments, right? Having some framework that you can experiment in and that you can try out robotics, perception, control concepts. I think that's critical. And if you happen to use MATLAB, this book will help you with that. But there are lots of different ways that you can use books like that.
Yeah, because we have a huge MATLAB fan base, I'm going to definitely put the link of your book in the description as well, so people can check it out, as well as the other books that you guys have written. That would have been actually my next question about the book, but maybe another question. What is your favorite robotics movie of all time? Maybe Peter, what's yours? And then Witek and then Remo.
There's a movie called Robot and Frank, which I really like, and it is about like an assistant robot that is given to a guy who used to be a burglar, and now he's like old and living in a home, and his children gave him a robot to keep him company. It's a beautiful movie. Unfortunately, the robot is somebody dressed up in a robot suit, but apart from that, it's a really good movie.
Okay. Witek, what's your favorite movie?
Yeah, I think Kubrick's, Space Odyssey, but that's also about the evil robot. But that is an amazing, amazing movie. And even if and it's old now, but if you watch it today, it still resonates. It's quite impressive. Yeah, I think I really like that one. And I don't know, maybe most people know, but the robot in there is called HAL, and that's just like a slight shift of the lettering that comes out from IBM. So
Yeah.
if you shift I to the left, it's H, and so on. So HAL is an IBM, so it's derived from that. Yeah.
That's
A little
good.
bit of history.
Nice. Remo, what's yours?
I love the Wall-E movie. It's like an animated movie, right, about a robot that compacts trash for a living. But besides the robot, the interesting aspect of that movie is, right, that it deals with this question that Peter raised earlier, right? Like, what happens if everything is automated? If everything is done by some robot, some machine around you, right? What happens to humans? It's just a nice parody almost of some trends that you see in society today, right? Be it obesity, or be it the obliviousness to climate change and the effect of the environment. But it's all in volley wrapped down around this love story almost about between this trash robot and a very advanced robot that seeks out plants. Anyway, that is fascinating.
Also a good one, though.
Yeah.
Also a good one. Maybe closing remarks from your side, guys. So anything you want to tell the audience, could be anything. And yes, I'm going to put the link to your book in the description, but anything people should check out, or maybe something you want to tell the audience. Maybe Peter again, then Witek, and then Remo. Anything we haven't covered, for example.
We've covered quite a bit of territory. I think that the important takeaway, I think, is that robots are going to be a very important and transformational technology in this century. The progress has been phenomenal during my working career, and given what's happening in AI, I think that robots are going to their performance is going to move beyond what I can even envision, I think, within 2 decades. So very exciting times ahead for people who are just starting their career.
Witek?
I don't really have that much to add to this, but I don't know. I think if you're interested in robotics, I'd encourage folks, try things out, learn, build your own robots, go out there and do it. I think that the practical aspects, the actual mechanics of doing it, the programming, learning, I think they're fantastic, and super interesting topic.
Yeah, I think robotics will be transformational, but it starts with baby steps, and we need more roboticists. So if you have kids, get them into robot clubs, get them into programming, get them into critical thinking about the world. Don't just use ChatGPT to answer your questions. But I think those skills, they are in a lot of ways taught and modeled, and I think we need more of that human capital to make the next generation of robots successful and transform society.
Excellent. With that, thank you so much, guys, for waking up early or staying up late from wherever you're from. Learned a lot, definitely, in this podcast. And yeah, I'm going to put every relevant link to your website, books, etc., in the description so people can check it out. And yeah, thank you so much. Hope to speak to you soon.
Thank you, Jousef.
Thanks very much.
Good day.
Take care.
Bye.